In this video, I will explain Gallagher's method for random construction of parity check matrix H of the regular LDPC low density parity check code. Parity check matrix is represented by parity check matrix is equal to capital H. The dimensions of capital H is M cross N. A regular N comma WC comma WR LDPC code is a code of block length N with M cross N parity check matrix. That is H dimensions is M cross N, where each column contains a small fixed number of ones. Each column contains a small fixed number of ones. WC is called as weight of the columns. That means the number of ones in the column is greater than or equal to 3. And each row contains fixed number of ones. Each row contains fixed number of ones. That is WR is greater than or equal to WC. WR is the weight of the row, the number of ones in the row. WC is the weight of the column, the number of ones in the column. This is the parity check matrix. The order of parity check matrix is M cross N. The weight of the column is represented by WC. The weight of the row is represented by WR, where WC is the number of ones in the column that must be greater than or equal to 3. And row contains fixed number of ones. The row contains fixed number of ones. WR is equal to WC or WR greater than or equal to WC. Either this one or that one. The number of ones in the parity check matrix H is equal to WR into M is equal to WC into N. WR into M is equal to WC into N, where WR is the row weight into M is the number of rows of the H matrix is equal to WC into N. WC is the weight of the column. N is called as block length. Weight of the row into number of rows or the number of parity check. M represents the number of parity check equation is equal to weight of the column into block length. This is the second point. The number of rows and the columns of the parity check matrix are here WR into M is equal to WC into N. In that regular N comma WC comma WR LDPC code is a code of block length N. We know the N value, WC value, WR value. From that, have to calculate M. M is equal to WC into N by WR from this equation. But H matrix order is M cross N. Therefore, M is WC into N by WR plus N. This one. The code rate of that regular LDPC code is R greater than or equal to 1 minus omega C by omega R greater than or equal to A by N. This is the main H matrix of order M cross N, or else this one is divided into WC submatrix. WC submatrices, each containing single one in each column. Submatrix. This one is H1 submatrix, H2 submatrix, and H3 submatrix, and so on and so forth. WHC submatrix. This one is the H. The matrix is divided into WC submatrices. The matrix means here H. parity check matrix is divided into WC submatrices, each containing a single one in each column. Single one in each column. Each submatrix size is, that means this one is sub H1, size is n by WR cross n. Another one. The first of the submatrices contains all ones in descending order. The first of the submatrices. The submatrices like H1, H2, H3, and so on, so for HWC. The first submatrix, that is H1, the first of the submatrices contains all ones in descending order. Ith row contains ones in columns. Ith row contains ones in columns. I minus 1 WR plus 1 to IWR, the size is n by WR plus n. Suppose 23 and 4. This one is n, block length n. This one is WC greater than or equal to 3. WR greater than or equal to WC. 4 is greater than 3. Okay. First, for the first row, H. For the first row means I is equal to 1. I is equal to 1. I minus 1 means 1 minus 1 into WR here is 4 plus 1, 2. 1 to I into WR. I means first row into WR means 4. Therefore, 1 minus 1 is 0, 0 into 4, 0. 1 to 4. 1 to 4. 1 to 4 means 1 to 4. 1, 2, 3, 4 up to block length is 20 columns. 1 to 4 here represents 1, 1, 1, 1. Similarly, for second column, I is equal to 2, 5, 6, 7, 5, 6, 7, 8, like that. In that fashion, I have to represent the ones in the original H matrix. Original H matrix. This is the first row. This one is the second row. The ith row contains ones. This is the first row, contains ones in columns. Ones in columns means from 1 to 4 columns only the ones are represented. The remaining are zeros. The size is n by WR cross n. That means n is 20 by WR is 4. 4 cross 20. 5 cross 20. This is the submatrix size is 5 cross 20. Later I will discuss with the example. WC minus 1 submatrices of the remaining WC is 3 minus 1, that is 2. In this example, the number of submatrices are 3. The first submatrix is H1 like that. The second submatrix and the third submatrix is represented by H2, H3. Here the size is 5 cross 20. Here also 5 cross 20. Here also 5 cross 20. The last two, this one is 3 submatrices, WC submatrices. Here WC is 3. 3 submatrices are represented by H1, H2, H3. How to frame the H1? By using this rule. The remaining 2 submatrices, WC minus 1 means in this example, 3 minus 1, 2 submatrices of size is 5 cross 20. Obtained by applying randomly chosen column permutations of the first submatrix. Randomly chosen column permutations of the submatrix. In each and every submatrix contains 1. The matrix is divided into WC submatrices, each containing single one in each column. Single one in each column. The concept will explain with the help of, for example, in this one. Here, example 20 comma 20 means here n, 3 means WC, 4 means WR. Here n is equal to 20, WC is equal to 3, column weight, row weight WR is equal to 4. WR is equal to 4. The H matrix of size is the H matrix size is in the second one, n into n WR by NWR by, here see this one, n into not WR, n into W, so C by WR, n into WC, n into WC by n into WC by WR cross n. That is the H matrix size is parity check matrix size is n is here 20, 20 WC is 3 by WR is 4 into or cross n is 20. Therefore, the H matrix dimensions is 15 cross 20. 15 cross 20. The H parity check matrix, see the H parity check matrix is 15 cross 20 according to algorithm is divided into WC submatrices. WC submatrices. WC submatrices of length or dimensions. Dimensions is n by WR cross n. That is n is 20, WR is 4 cross 20. That is 5 cross 20. 5 cross 20. The H is divided into 3 submatrices. WC is 3 submatrices. Each submatrix size is 5 cross 20. Main H parity check matrix size is 15 cross 20. 15 cross 20 is divided into 3 into 5 cross 20. Now develop H matrix by using these 6, 7 points. Now the block length is 20. Here block length is 20. 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 1, 13, 14, 15, 16, 18, 19, and 20. Each first submatrix of size is 5 cross 20. That means 5 rows. That means 5 rows. One, 2, 3, 4, and 5. First submatrix is framed. How to frame this submatrix is very, very important. Of size 5 cross 20. This is the first submatrix. 10. This is the first submatrix. The rules are the first submatrix means here is we use this one. First I minus 1 WR plus 1 to IWR. How to print the first I minus 1 here I minus 1 into WR plus 1 to IWR. For the first row, I is equal to 1, 1 minus 1, WR is 4 plus 1 to I is equal to 1, WR is equal to 4. That is for the first row, 1 to for the 1 to 4, 1 to 4 columns. The first row, the ones contains columns are 1 to 4. For the first row, the ones contains columns are 1, 2, 3, 4. 1, 2, 3, 4. This one is 1, 1, 1, 1. Next one. For second row, I is equal to 2. 2 minus 1 into WR is 4 plus 1, 2, 2 into 4. This 2 minus 1, 1 into 4, 4 plus 1, 5 to 8. 5 to 8. 5 to 8. For the second row, the columns contains ones are 5, 6, 7, 8, 9. 5, 6, 7, 8, 5, 6, 7, 8, 1. 5, 6, 7, 8. 8 up to 8. For third row, I is equal to 3. 3 minus 1 into 4 plus 1, 2, 3 into 4. 8 plus 1, 9 to 9, 10, 11, 1, 9 to 12. 9 to 12. For the third row, this one is third row. The columns contains ones are 9, 10, 11, 12. That means 1, 1, 1, 1. Next one, I is equal to 3. For fourth row, I is equal to 4. 4 minus 1 into 4 plus 1 to 4 into 4. 4 minus 1, 3, 12 plus 1, 13 to 16. 13, 14, 15, 16. That is 13 for fourth row. 1, 1, 1, 1. Finally, for the last row, I is equal to 5. I is equal to 5. 5 minus 1 into 4 plus 1 to 5 into 5. 5 into 4. 5 into 4. 4 minus 16, 17 to 20. 17 to 20, all are ones. The fifth row contains the column. The fifth row, the ones which are placed at the columns are 17, 18, 19, 20. 17, 18, 19, 20. The remaining all are zeros here. The remaining are zeros. The remaining are zeros. Here zeros, the remaining are zeros. This is the sparse submatrix. Less number of non-zero. Less number of non-zeros means ones. More number of zeros. Coming to next submatrix. Okay. First submatrix contains all ones in descending order. Descending order means here for the first row, the columns are 1, 2, 3, 4. For the second row, descending order 1, 5, 6, 7, 8. For third row, 9, 10, 11. Descending order. This one is the descending order. Next one. For the first of the submatrix, this is the first of the submatrix contains all ones in descending order. The size is like that. Okay, next one. The matrix is divided into W submatrix. Each contains single one in each column. Single one. This is the column one, single one. First column, single one, second column, single one, third column, single one, fourth column, single one, fifth, and up to 20 columns. Each and every column contains single ones. Next one. Second, WC minus 1 matrices. That means WC here is 3, 3 minus 1. Again, two submatrices. You have to frame two submatrices. You have to frame two submatrices here. You have to frame two submatrices of that H parity matrix. This one is 1, 2, 3, 4, and 5. In this example, 15 cross 20 is divided into 3 submatrices. Each of length is 5 cross 20. Dimension is 5 cross 20. Second one here, we have to frame second one. 1, 3, 4, 5. This one is another 5 cross 20. In this point here, WC minus 1 submatrices of size again n by WR and 20 by WR is 4. 20 by 4 is 5 cross 20. Here 5 cross 20 obtained by applying randomly chosen column permutations of the first submatrix. Column permutations. Column permutations. Here column permutation. Now we will see column permutations. Here 20 columns are there. Here 20 columns. Column permutations means columns are changed. Here 20 columns. Here one way here is again each column contains single one. I will follow some simple method here. First column, put one here. The remaining all are zeros. That means first column of the first submatrix is taken as first column of the second submatrix. The remaining are zeros. Here contains single one, that is satisfied. Each column of the submatrices contains single one. Coming to next one here, put one here, and put one here, and put one here. Column 1 is completed, 2 is also completed, 3 is also completed, 4 is completed. For these 4 columns, each column contains single one. The remaining all are zeros. The remaining are zeros. Here, put zeros. Put zeros. Coming to this one. For the second one, here, fifth column, 1 here. For the sixth column, put 1 here, and third one, here 1. For the 5, 6, 5, 6, 5, 6, 7. For 8, 1, put 1 here, put 1 here. For fifth column of the second submatrix contains single one, sixth one, single one, sixth column, single one, seventh column, single one, eighth column, single one. Randomly chosen. These values are randomly chosen. The remaining all are zeros. The remaining all are zeros. Coming to ninth one, ninth column. For ninth column, here, put here 1, ninth column from the first, second submatrix of first row is here, put 1 here put 1 randomly. Next one here, leave it. Next one here 1, here 1. One more important point here is a very, very important point. Here 1, 1, 1, and 1. 1, 1, 1, 1. Ninth is also completed, single one. 10 is also completed. 11th one is also completed. Here 12th one is also completed. The remaining all are zeros. Coming to 13th column. Coming to 13th column, here put 13th column. Put 1 here. 13th column is also completed. For 13th column. One here. The total number of weight column WR is 4. How to maintain that one? WC is equal to 1 here. WR is equal to 1, 2, 3, 4. 1, 2, 3, 4. Here 1, 2, 3 is there for 14th column. For 14th column here 1, 2, 3. Here put 1 here. Put 14th column, one more important point here is the 14th column. One here, 1, 2, 3. Here 1, here 1. 13th is also completed. 4th is also completed. 15 is also completed. 16 is also completed. The remaining all are zeros here. Up to this one. For last one here. For last one, 5th column here. Here 1, 2, 3. You have to maintain column weight is 4. Put 1 here. 17 is also completed. Here 3 ones are there. Here put 1 here. 18 is also completed. Put 1 here. 1, 2, 3, 4. Put 1 here. 1, 2, 3, 4. Here original matrix is 15 cross 20. 15 cross 20. Column 8. WC is equal to 3. Row 8. WR is equal to 4. Here row weight 1, 2, 3, 4. First row. First row of the first submatrix. Row weight is 4. And second row weight is also 4. Third row weight is also 4. Fourth row weight is also 4. Fifth row weight is also 4. You have to maintain that strategy. For a second submatrix, row weight is 1, 2, 3, 4. Here 1, 2, 3, 4. 1, 2, 3, 4. Here 1, 2, 3, 4. Here 1, 2, 3, 4. Here 2 ones are there. Here column weight is each column of the submatrix contains at least 1. At least 1. Okay. Next, generally column weight is main H matrix column weight is 3. So 2 submatrices weights. First submatrix column weight is 1. Second submatrix column weight is 1. Adding these two, 1 plus 1, 2. Have to create another third submatrix. Each column maintain in that each column maintains again 1. 1 plus 1 plus 1, 3. Now we will see that third one design. Here the remaining are zeros. One more important point here is WC minus 1 submatrices of size n by W are cross n obtained by applying randomly chosen column permutations of the first submatrix. Column permutations means here second submatrix, first column is this one here. Here first one. Second one is fifth one. This one is first one. First one of the submatrix. This one is fifth one. This one is another one is ninth one. In that fashion, you have to randomly interchange the columns of the first submatrix obtain second submatrix of the H matrix. Now we will see the third one. one is 1, 2, 3, 4. This one is 5. 1, 2, 3, 4, 5. This third submatrix. WC submatrices are there for original H matrix. Again, here I have to apply column permutations of the first submatrix. That is a difficult task. That is the reason I will follow this procedure. Just you have to put ones randomly and see the covered columns. Each column contains one element, one number. Here, 1, 1, 1. Here 1 and here 1. 1, 2, 3, 4, 5 columns are completed. Here 5 columns are completed. The remaining are zeros. Put the remaining are zeros here. The remaining are zeros up to this one. Randomly selected. Randomly selected here. The criteria satisfied is each column of the submatrix contain at least one. Here, third submatrix, first column contains 1, second column contains 1, third column contains 1, third, fourth and fifth satisfied. This one is satisfied. Coming to next one. Sixth column, seventh one, eighth one, ninth one, and 10th one. This one is the remaining are zeros. The remaining are zeros. Coming to 10 completed. Next one 11. Randomly put ones here for 11. Here put the second row. Here 1 here. 11, 12, 13 here for 3 third row. Here 1, here 1. 11th row is also completed. 12, 13, 14, 15. Here remaining are zeros. 0 here. The last one is here is here randomly put ones here. How to maintain force. Here 1, 2, 3. Column weight is 4. Here for 18 here some put here 1. 18 is also completed. 19, 20 here for second row. Here for second row here put 1. Here put 1. These two are also completed. 17th, 16th are also completed. 4 ones. 1, 2, 3, 4. Here 1, 2, 3, 4. Here 1, 2, 3. You have to maintain another 1 here. You have to maintain another 1 here. 1, 2, 3, 4. With this, the submatrices design completed. 3 submatrices of length 5 cross 20. The second and the third submatrices are obtained by permutations of column permutations of the first submatrix. Simply change the columns of the first submatrix for designing of second, third submatrices and satisfy row weight and column weight. Here 5 cross 20 is the first one. Column weight here is WC is equal to 1. Here second one. Column weight is also 1. Here the third one, column weight is 1. Add these 3, the column weight is 3. WC is 3. WR is equal to, in each row having some 4 rows. This one is 4, this one is 4, this one is 4, 4, 4. Here also 4. Here also 4. Here also 4. Therefore, N is 20, WC is 3, WR is 4. By using this procedure, the main H parity check matrix is designed. With this, the design of this one is capital H matrix, parity check matrix of the LDPC code. The design of that LDPC code is based on the Gallagher's method for random construction of parity check matrix H of the regular LDPC low density parity check code.